Okay, let's move on to the last section for problems of this chapter. Okay, so there are two candles, right, made the same length, but different materials, so that one burns. Okay, so one burns out at the rate of 3 hours, and the other is 4 hours. So one burns faster, 3 hours are gone, and the other is 4 hours. Okay, so this is how long take out to burn one candle, right? So basically the question is, we have the two candles, okay, and we have the time, right? So we can calculate the speed. So for one candle, right, each hour it can speed of the 1/3, right? For the other one is each hour it can burn the 1/4, right? The length is 1, okay? This is how we normally treat with the relative things. Okay, we can assume one thing is 1 to make things simple. So at what PM should the candles be lit so that at 4 PM one stub is twice length of the other one? Okay, so let's don't think about the starting and stop point yet. Okay, let's think how long does it take for one handle to be twice as long as the other ones. Okay, so at the very beginning they are all at 1, right? So one burns faster means after t times, right? After t hours, okay, the shorter one is this, right? And the longer one, the rest of length is this, right? So the shorter one times 2 is equal to the length of the longer one, right? When you solve this, okay, you can solve t equals the 12 over 5 hours. Okay, so if you know that t is equals 12 over 5 hours is about 2 hours and 24 minutes. Okay, so you want at 4 p.m. it already burned the 2 hours and 24 minutes, right? So the start time is equal to the 4 p.m. minus the 2 hours and 24 minutes. So you have to start burning at 1:36 p.m. 47. Okay. So A and B travel around a circular track, uniform speed in opposite direction. Okay, so A and B must travel in opposite direction, starting from diametrically opposite point. Okay, what the diametrically opposite point means this, okay? It's starting from the A. This is the starting point from the B, okay? They are travel in opposite directions. If they start at the same time and starting at the same time, starting location here, and meet B and meet first after B traveled 100 yards. For example, this is the first meet, M1. B have traveled 100 yards. Then they meet the second time 6 yards before A completes the whole lap. So this is the second meet. Okay, so now let's see. It let you calculate what the circumference, right? Let's say the circumference is x. Because they're starting at the opposite diameter, right? So this arc, let me use another color. So this arc, the length is half of the x, okay? So this arc is the length of the half of the x. Now let's see, when in their first meet, they travel what? They travel the half arc, right? Half of the circumference. So it's 2x minus 100 yard is where the A travels, and the 100 is where the B travels, right? So now we can set up equation is half of the circumference minus 100 yard is the A travel over the first meet time, and the 100 yard is equal to the B speed times the time that B used at the same period. Okay, now we have the M1, right? This is the M1. For the M2, right? So you can see A travels 60 yard before the second meet. So A travels this amount, VA times T2, right? And the B travels half of the arc, half of the circumference plus the 60. Okay, now we have the equation, right? Let's see how we can solve this equation, okay? It's not black. Okay. Yeah, now let's see how we can solve this equation, okay? So you can see the 4 over 3 equal to the VB over the VA is also equal to the 2 over 1. Okay, so now we have the equation is x over 2 plus 60 divided by x minus 60 is equal to the 100 divided by x over 2 minus 100. Now we can do the cross product, right? So we can have the x over 2 of the square minus the plus 30x minus 50x is minus 20x. Then minus 60 times 100 is equal to 100x. Then minus 60 times 100. So you can see, well, this is gone, right? And the circumference can be either 0, right, or something else. It cannot be 0, right? So x cannot be 0. So now we have the x over 4 minus the 20 is equal 100. So x equal to 480 unit is yard. Okay, next. So C and B can demolish the building in 6 days, and Annie and Bob can do it in 3 days, and Annie and Carl in 5 days. So how many days does it take all of them to working together if C gets injured at the end of the first day and cannot come back to work? So this is the working efficiency issues, okay? Now let's set up the working efficiency. What are the working efficiency? Let me explain a little bit. Okay, so if a work we define as 1, okay, it takes the A 10 days to finish, the A's working efficiency is 1 over 10. Okay, so it means it takes 10 unit of the time for A to finish, right? The unit time, it can be days or hours or whatever. So this is the efficiency. Okay, let's say it takes 8 days for single A to work. Then A's efficiency is 1 over A, right? 8 days for A to finish. B days for B to finish. And C days for C to finish. Okay, A, B, C are days for A, B, C individually complete. Okay, Now what we have is here, okay? So the whole work using A's efficiency plus the B's efficiency is 3. The whole work, okay, for the A's efficiency plus C's efficiency is 5. The whole work use the B's efficiency plus C's efficiency is 6. Okay, this is the equation we set up, right? So it says we want to use the A, B, C's efficiency, right? So we can have the A's efficiency plus B's efficiency equals 1/3. Then A's efficiency plus C's efficiency is 1/5. And B's efficiency plus C's efficiency is 1/6. Okay, now we can know that the A plus efficiency of the B plus efficiency of the C is half of the 1/3 plus 1/5 plus 1/6, okay, is equal to 7/20. So means after 1 day and the ABC works them together, right? It can every day it can finish 7/20 of the whole project. So this is the first day they can finish, and the rest of the work is 13/20, right? But after the first day, the C cannot come because he got injured, right? So the time it take is 13/20 for the rest of the project, right? We have to only A and B can work, so we only use their efficiency. So it's 13/20 over 1/3, right? This is how many days? It's 39/20, right? This is how many days they can complete the rest of them. So the total is 1 day, right? They work together, plus 39/20 is 59/20 days. Okay, final question. The Z, okay, Z's mother, Wilma also picks her up at the train station when he comes home from the school. Then Wilma drives the Z back to home. They always return home at 5 p.m. One day, Z left school earlier and got the train to the train station an hour earlier. Okay, an hour earlier, 5 p.m. Then she started work at home, and Wilma left home at the Euro time to pick up. Okay. So here, right? So normally is Z arrive at the train station, and her mother Wilma is already here. Then they drive back home and arrive at the 5 o'clock. Okay, one day, because they arrived here earlier, right? So she start to work. Okay? And her mother Wilma also starting as leave the home at the same time, so meet her somewhere here. Okay? Meet her somewhere here. Then Wilma end up drove back to home and arrive at home at the 4:48. Okay. This you can think, okay? Because the Wilma drive less distance here, right? So that's why they can save the time, right? Let's see how many time they save. It's from the 5 o'clock minus the 4:48 is 12 minutes, right? So the Wilma saved the 12 minutes by driving here and driving back the 2 distance, right? the delta D. The 2 of the delta D is what she saved. She saved to drive less time by driving less, right? So the 2 times delta D is equivalently less driving, 12 minutes. So means it only saved the 6 minutes, right, for a single delta D, right? Okay, so it saves her the 6 minutes to drive here, right? Means what? Means the Z already work for 60 minutes minus the 6 is 54 minutes. Okay, so that's why the answer is 54 minutes. Okay, so that's wrap up for all the challenge problem to this chapter. Thank you.